Do you know how strong the gravitational pull of a black hole really is? Why is it said that even light cannot escape from a black hole? We know that anything captured by a black hole will eventually be devoured, leaving not even a trace. But light is different from celestial bodies. Light can circle the Earth 7.5 times in just 1 second. It is the fastest known speed in the universe, and the mass of light is nearly zero. So why is it still relentlessly swallowed by a black hole? Before answering this question, we must first understand what gravity is and how it is produced. Newton's law of universal gravitation tells us that there is a gravitational force of attraction between any two objects. The greater the mass of an object, the stronger the gravitational pull it generates. And the closer the distance between two objects, the stronger the gravitational pull. Conversely, the further apart, the weaker the force. This means your body and every person on Earth have gravitational pull between them, just too small to notice. But a black hole's gravity is extraordinary. It is formed by the collapse of a sufficiently massive star, with all its matter compressed into an incredibly small volume, resulting in an extraordinary density. Thus, it possesses the gravitational power to devour even light. But if light has no mass, why is it affected by gravity and can be swallowed by a black hole? In fact, according to Einstein's general theory of relativity, gravity is the result of curved space-time caused by matter. In other words, a massive object will cause the surrounding space-time to bend. Imagine space-time as a piece of fabric. Placing a heavy object on it creates a depression. This depression represents the curved space-time. Anything placed nearby will fall into the depression, just like the way curved space-time works. More accurately, light has no rest mass. We know light is made up of photons. Although photons have no rest mass, they have momentum. As mentioned above, gravity is caused by curved space-time. So when light travels through the universe and passes near a massive celestial body, its originally straight path is bent due to the distortion of space-time. This is why light's path is forced to bend. For example, in the photo taken by the Hubble Space Telescope, you can clearly see some galaxies appearing in distorted shapes. This is because the light they emit passes near massive celestial bodies and is affected by the bending of space-time. This is the gravitational lensing effect predicted by general relativity. But a black hole is no ordinary celestial object. If the Earth were compressed into a black hole, it would be the size of a grape. Imagine the density and mass of a real black hole. Space-time becomes extremely warped. Light doesn't just bend around it. It falls into the funnel-like space-time. So even light cannot overcome the extreme curvature of space-time and thus cannot escape the powerful gravitational field of the black hole. Therefore, any object, including light, once crossing the event horizon, the boundary of the black hole, can never return. This also means we cannot directly observe black holes. Even if we flew a spacecraft into a black hole and managed to uncover its secrets, the data could never be transmitted back to Earth. As a result, the ultimate mystery of what lies inside a black hole may forever be sealed within it. And we humans may never be able to truly unravel the mysteries of black holes.